Good morning, guys. We will start at 9:05. So I will send you the files for today's workshop, so you can download it in case you need it. Okay, I hope everyone can see my screen. So welcome to today's workshop. It's data analysis and visualization using Pandas and Matplotlib. So my name is Hao Ji. I'm the data scientist at CARC. Here's a brief overview of today's workshop. We'll first introduce some basics about Pandas Matplotlib, and then we will go more in detail about what is Pandas, what is Matplotlib, and then in the meanwhile, I will give you a IPython notebook so you can exercise what was discussed in today's workshop, and then we will just give you a summary at the end. Before we get started with the main content, I'd like to introduce you some of the CARC on-demand feature. So if you're on your browser, you can type carc.usc.edu. I hope you are following me. So because we're using this on demand for our workshop. So if you go to this website, carc.usc.edu, and if you go to user information, there's a tab is called CARC on demand. So if you click on this, and they will direct you to this page. Then you can click login to CARC on demand. If you're not on campus, you need to use Cisco AnyConnect to connect to the USC VPN in order to log into CARC on demand. It might ask you to input your dual authentication. So I'll give you a couple of minutes, maybe 2 minutes, so that you can log in to this web page. So if you're done, you can just let me know. You can either type in the chat or you can just give me a thumbs up so I know everyone on the same page so we can proceed. Or if you're not at USC, you have to use a client called Cisco AnyConnect. Let me check. But it might take a while. But it's okay if you don't have Cisco AnyConnect for now. I can still go over the lecture slides. You can do the practice later. I can show you because during June we changed our network settings. So if we're not on campus, you have to use a VPN. This page shows how you can connect to a USC VPN. I'll put in the chat in case anyone need this information. So I hope everyone is on. Okay, cool, nice. So I will go through several different features of Kafka on demand. For example, the Kafka on demand, we have different parts for different storage. So you have your home directory, you have a project, you can also have your scratch directory. For this, I mean, we use your home directory. We can use it for now. You can also choose to put the files. I sent you 3 files. One is a CSV file. It's for importing the data. It's a data file. And another one is IPython notebook. So that notebook you can use for executing your scripts that was written in Python. Another one is just a PDF of my presentation. For example, this is my home directory. So today, we will just go to the workshop folder. You can also create a folder if you want. So for example, you want to create a folder, you can just click on new directory, just give a name, and it will show up something like this. And today's workshop is data analysis visualization. It takes a little bit, like maybe 1 or 2 seconds before every content was loaded. I already put the file over here, but if you can put the CSV file and an IPython notebook in a specific folder that you named, that would be great. So for example, I want to upload some files here. You can just browse the file, you just download it and then put it here. Drop the files over here, and then it will show, the file will appear under your folder. USC Guest will not be able to log into the portal. So you have to connect to USC Secure. Okay. Since someone might be new to this on demand, so I'll give you 2 minutes so that you can. Oh, yeah. Okay, maybe you are a little bit, I can put the file over here. I'll put the file again in the chat since someone might come a little bit later, so you can download it. One is a PDF file for today's workshop. Another one is IPython notebook file. Another one is a CSV file. So you will use a CSV file and IPython notebook for today's workshop. Just download it and then practice using the upload feature. So upload this 2 files, solar system abbreviation.csv and also workshop -pandas matplotlib.ipynb. That stands for IPython notebook. Okay. I think it shouldn't be really hard, so I assume everyone won't have any issues. In case you still have problems with AP and VPN, don't worry about it. I'll go over the main content of lecture. You can do it offline if you want. Okay, once you upload the file to your folder, and then you can create an interactive session. So you see where my cursor's at. So there's a tab, it's called Interactive Apps. Click on it and then click on Jupyter Lab. Okay, so it gives you a bunch of options, whether you want to use a Discovery cluster or Endeavor if you have Endeavor. I mean, you can leave it as default. I mean, your account name, that's default. We just use a main partition. Number 1 CPU is fine because we're only doing data analysis. Memory is the default 2 GB of memory. For us, it's enough for today's workshop. Number of GPUs, the minimum is 1. So we're not using GPU for today's analysis, so 1 is enough. So for the number of hours, I would suggest you do 2, because the workshop's 2 hours, in case we don't want to go over the limit. So 2 hours, and then once you're done, you can click on launch. That means this is kind of something you use when you request for resources, just like the Slurm script. And then right now we're requesting 1 node, 1 core, so the system trying to allocate some certain computing resources for our session. So we're using the Jupyter Lab. So once the session is trying to, you see the status shows starting. So that means you're almost there to get your resources. And once it's up running, it will show something like this. So before today's workshop, so I already request an active session. So once it's done, for example, you can just go to, you can just click on connect to Jupyter. And it will ask you if you want to create what kind of notebook you want to create. You just, the default is Python 3. I mean, for me, I have some bunch of other stuff. Probably for you, it's only this one. So just click on this, Python 3. And you will give a default, which is untitled. So you want to go to your folder, for example, today's workshop. So on the left, it shows all your home directory. So you can also navigate through your project. So I already have a IPython notebook folder. So if you double click, then the IPython notebook will show over here. You can just unclick this discard if you want. I mean, that's not what we want for this workshop. So I hope you can get this file up running. You already have something on the left, see like number 2, number 3, that because I ran it beforehand. So if you want to start with a brand new Jupyter notebook, you can just click on kernel, restart, and clear all outputs. That will clear all the stuff in the notebook. Okay, someone's still in queue. But I will wait for 2 or 3 minutes. If you're trying to navigate the file system, you can just click on this. The default is your home directory. It's on the left. The Jupyter Notebook should use your default home directory. I can't find that. Okay, someone might have issues with their open on demand, and don't worry about that. We will go through the lecture. This feature is just for you to give you a little bit practice, but you might have issues, but we can troubleshoot afterwards. It's not a very big deal because the main content's in the lecture slides. We can troubleshoot later on because it might take a while to troubleshoot everyone's if you have errors loading on demand, etc. But don't worry, you can also practice offline using your own. If you have Anaconda, you can also load your Jupyter Notebook as a practice. Okay, since it might take a while to troubleshoot, so let's just go proceed with a lecture. Okay. We already talked about this. So let's jump to the introduction. So we'll first talk about Pandas. Pandas is a powerful and flexible tools you can use. It's mainly for data analysis and manipulation. It's built on top of Python, so you already use Pandas on top of it's a package from Python. You can import it and then use it for your needs. And the goal for this intro is that you can describe how the value of Panda is to the data science. Also highlight the different key structures of Pandas and discuss its capabilities in widespread adoptions. Here are some key benefits of Pandas. For example, it supports a variety of data. And it supports NumPy, you can load CSV file and also JSON, different formats. I can also load time series data. And then you can also use Pandas for data transformation and integration. And lastly, you can use for visualizing your data as well. Here's the overall pictures what Panda does. You can import it from different formats, from different data formats. And then after you import data, you can transform it. And at last, you can visualize it. So there's a bunch of options. You can visualize it, histogram, bar plots. And then we will go more in details that talks about Pandas. There are two different types of data structures of Pandas. One is called series. Another one is called data frame. The series one-dimensional labeled array. You consider your data, for example, you can have a bunch of data. Series is a data with one column. The data frame has several columns. That's the main difference. And then it can support many data types, as I said, like you can use CSV, you can also use some other data formats. The access labels is called index. So you can use, you can access your data with different index. And mostly also you work with NumPy. I think most people are familiar with NumPy, but if you're not, NumPy is just a fundamental package for computing in Python. It loads multi-dimensional array objects. We will talk about later. So here's some commands we can use for testing our series script. For example, we can create a data using NumPy. Random.ram, it just creates data, five data that's in the range of 0 to 1. For example, let me execute it. For example, on the right, I have a notebook, right? So I've imported data. I'll import a NumPy, import pandas, so we can use these two packages. I give a NumPy random seed. That's for controlling the random seed generator. For example, if you put some random stuff over here, every time if you execute at different times, it will give you different results. I wanted to replicate result, so I need to control the seed number so that I will output the same stuff, although it's kind of random, but it has a random seed generator. If I control the random seed generator, it will output the same result every time. So if I create the data and then make it panda.series object, and then it will show up something over here, which is actually the same on the slide, right? So it will give you a 5 number. Each number is from 0 to 1. And then it's a panda series object for now. And then if you want to go more in detail, for example, you think, okay, the number on the left, which is called index, it's not really meaningful. So I can just give an index to the data, which is same data, but I give the different names, for example, astronomy, geology. So then I create a panda series object, and it will be something like this. Okay. Another one I talk about is data frame. Instead of one column data, a data frame can be multiple columns. So in order to create a data frame, I can first create a NumPy array, which it's 1, 2, 3, 4. It's 8 rows, 4 columns. So this is a NumPy object. So how can we create a data frame based on NumPy object? Then we can just type in the command like this. We also have it in the Jupyter notebook. So if you want to execute it, you can just type Shift Enter. So I execute this command. I believe you can also do this, run. Then it will just run it. Yeah. If you click on this right arrow, you also run specific lines if you want. Okay. And then, so if you give a panda data frame object, and based on the NumPy data, and you give it different columns and different indexed columns, we have 4 columns, we have 8 rows. So once you're finished, and it will show up something like this. And this is a perfect format for structured data. You can use it later on for different data analysis and visualization. Once we have the data, right? So how can we integrate the data? So not every time that you have to create the data from raw, right? So it's kind of tedious to create the data manually. Most of the time you already have a file, right? For example, you have a CSV file. You just want to import this file. So then we can see the Panda supports different formats for importing your files. You can have CSV file, have JSON, HTML, can also use SQL query and SQL table database. For example, I give you a file, it's called solar system abbr.csv. So we can try to import this file directly to and convert it to a Panda data object. Let me first execute this. So the solar system CSV file is in my folder, right? It's in my current path. So if I just use panda.readcsv, and it will just import the data in this file. It's kind of convenient. You don't have to type in every object in this file, and it automatically loads all the stuff in here. And basically on the left in the slides, we have the same stuff as shown on the right in the notebook. We can also read the JSON files. That's just something for you to know, because JSON file format is a little bit different. You might not use it very often, but it's good to know that you can have, it has some functions like that. You can also read the HTML file from Pandas by using this function, pd.readHTML. Another one is called read SQL query. In big companies, they have SQL database and it can be really big. So the reason why they use SQL is kind of, you can query the data at a relative faster speed. You can also read the SQL table. The SQL table is something that looks like this. It's a structured data looks similar to Excel, but it's mainly for large amounts of data. Once we load all the data, index option, index column 0, and that's a default. Like if you wanna, for example, this line is doesn't count as the column, so you will start with a column like this. Otherwise, you will use this one as index 0, which you probably don't want this as your index of the column. Okay, thank you for your question. And then after you load your data, you also want to see, okay, what my data looks like, right? You want to give a overall idea of what your data is. For example, you want to describe some statistical analysis, perform some statistical analysis on your data. And one simple command is called describe function. Okay. Let me see. Okay, cool. So we already have this solar system object. So if you type in solar system.describe, you can see, okay, then counts means there are 14 rows index in this data. And then you will give a mean value of, for example, the order from sum. What's the mean value of this? It's 4 points. It's 6.5. And also what's the standard deviation, the minimum 25% interval, and the maximum number of this row. The reason why it's helpful is because you can easily identify if something wrong. What if, for example, some data cannot be negative? If it's a minimum is negative, that means the data is off. So you want to double check your data, what's wrong with data. And also, for example, diameter. And if you can have different values for 50%, what's a 50% of diameter? It gives you an overall idea of what your data looks like. There are a bunch of other functions, but I just want to let you know they exist so you can test it out later. When you have time, you can have mode. You can also test if any value within for a specific circumstance. And then after you load the data, as I mentioned, some data might be off. They might not be useful. So you want to clean your data because in real life, data is not clean. You might have missing values. You might have outliers. You might have NaN value. For example, when you're working on a project, sometimes your machine just doesn't generate any output. It'll give you a null value. What if you want to do, how can you do with those data? For example, I have a data like this, it has 9 rows, 2 columns, but some values I see, okay, 9,999. It's something that really off, and I don't think it's what I want. So I want to replace it with 0. So after loading the data frame, I can just type df.replace and then put this number over here and then replace with 0. And after you're typing a command, your data frame will look like this. Okay, do this. It's the same data array as shown on the slides. Okay. And then some data you don't even want it. you just want to drop the data. For example, NaN value, it doesn't have any doesn't have meanings with this value. So I just want to delete the rows of the data, right? I can just use axis equals 0. That means this row, I want to delete it. And for this row, because it has NaN, and then we'll want to delete this row. If you specify axis equals 1, you will delete the columns with this NaN value. So you see column 0 has NaN, column 1 has it. So only column 2 will be will only stay. Next, we'll talk about data visualization, right? So most people like to visualize data. At least, I mean, people are very good at visualizing data rather than reading, writing, because it's kind of give you overall idea of your data. For example, I have a data frame like this, 9 rows, 3 columns. If I just want to have a rough plot of a bar plot, and for example, I have different rows. Each row I plot a bar plot based on the data. It's based on different columns, 0, 1, 2. It doesn't look that nice, but at least you can have an overall idea how your data kind of transforms, how your data looks like. And if you want to plot in more detail and in more, for example, if you use scientific publication, you can also switch to Matplotlib. I think a lot of researchers use Matplotlib for plotting. It looks nicer. And also for data frame, you can also use it's a box plot. So I think most people already know this box plot. So there's a minimum, maximum, 50%. I mean, give you an overall idea how your data distributes. And it's based on different 3 columns of data. And you can also plot the histograms. Because we have 3 columns of data, it looks a little bit noisy. So it's a good idea to just plot 1 column data, see how your data distributes. You can also just use the df.plot function. It will create a line plot that looks something like this. There are more advanced features. You can, change the color on the position of your legends, and you can go into more details if you want. The next section will talk about frequent data operations. Most of the time, you also want to, handpick some rows or columns in data. Want to delete or add some rows in the data frame. Sometimes you want to do some aggregation functions. It's called group by. So we'll talk about this in this section. For example, you have 3 columns data, but for some reason, you only want to use sensor 1. That's your focus. So I don't want this data. What should I do? Then when you have this data frame, you just give a name on the right. Then you just select sensor 1 as your input. Then you will output only 1 column from this data frame. Then you can work on this later on without worrying about the other columns. Sometimes you want to, for example, you want to get the data from sensor 2 that's, that's above 0. You don't want to handpick every data because there can be tons of data there. So you just give a criteria on the right. So I want the sensor data which is above 0, and then I put this equation over here. Then it will only give you the data which the data in sensor 2 is above 0. Then the rest of the data is gone. Also, if you want to do some data operations, for example, I have this data frame, but I want to create a sensor for data frame column. That's based on sensor 3. And I want to take a power of every data in this column. What should I do? I just give a function to the power 2 to the sensor 3, and then I create a sensor 4 data frame. Then afterwards, if you put the data frame command over here, it will show that, okay, now you have a data frame that has 4 columns. Another operation some people do not really frequently, but you might also encounter is that you want to create another row of data just based on this data frame. So you use the lock command. I think it represents for, it stands for location. So df.lock. So I create another row of data, which is index 10. I gave 4 values, 11, 22, 33, 44. Then after you put this command, execute this command, you will have another row of data. And if you want to drop a specific row, and you just use df.drop, specify a row number. For example, I don't want this index 5 data. If I execute this command, it will give you something like this without the index 5. What if you want to delete a column data? It's also possible. For example, I don't want the sensor 1 data. I just did del, delete it, and then they'll only have the rest of the 3 columns data. It's a good idea to just import all your data, and then you can just select your specific data. Delete is also option, or you can create another data frame object. Remember, we specify the sensor data we want. You can also specify the ones you want instead of deleting something. The last one we do data frame operations is a little bit advanced feature. It's called group by. As the name suggests, it's kind of group by a certain stuff based on your command. For example, student ID, we can see, okay, there's 3 there's 3 rows of data with same student ID 2. There's 3 4s from row 3 to row 5. There are also student ID with 12. There was only 1 student with student ID 100. So instead of looking at all this data, I just want to group by based on the student ID, right? So I just use group by function. I want to calculate the mean within each group. For example, student 2, for example, if he has 3 exams, midterm 1, midterm 2, final, what's the mean value of this person's physics exam? So if I use group by student ID 2, I see, okay, he got a mean value of 115 all of the 3 exams. So not sure whether it's good or not, but at least we can, by using this command, you can quickly get an idea of the stuff that you want. Something we want to do also often, maybe if you work in big companies, you have different types of data frame, CSV files. You want to merge different CSV files together, right? So that's when you want to merge your data frames together. For example, I have a data frame which is called left, and it looks something like this. It has 4 rows, different columns, key 1, key 2, city, username. Right, another data frame is called right. I name it because it's kind of easy to understand. So left data frame, right data frame, and then it has some similar keys, but instead of city username, it has hire date profession. What if I want to merge them? So if I want to merge left data frame with left data frame, so I just use a concatenate function. Okay, and then if you do concatenate function, then you will just append the same object underneath this one. SQL is more for SQL can also be used for data, but for example, I'm not sure whether SQL can be for data visualization. It's mostly for big companies for manipulating very big data frames, CSV files. For pandas, it's more like for smaller files, file sizes, and also give you more advanced features if you want to do some plotting, you want to do some analysis. It's easier to learn. SQL also has some commands you can use, but it's mainly for big companies. You need to have an SQL database in order to use that. I think that's major difference. Not many people like SQL because Panda is probably a little bit easier to learn. So hope that answers your question. I could be wrong because, but based on my understanding, most people who use SQL is in big companies. They have very large database, really big, like tons of data, several millions, maybe 100 gigabytes of data is something that they do normally. So if you use SQL, that would be faster. Panda sometimes based on there's some limitation. For example, if you import many Excel files, your system might be slow, but SQL could be faster. And you can also concatenate your right data frame to your left data frame, because as I mentioned, some of the columns are different, so it will give you some n values. But afterwards, you will concatenate the right data frame to the left data frame underneath this one. You can also use the append option. So that's just two options you can use. You will output the same result. Okay, then I'll give you a brief overview kind of a summary of what we learned in pandas. I hope it's not too much for you guys, but this is just some basics you want to learn for using pandas. I think the best way to learn pandas is to do, for example, you have a Excel file, for example, COVID data. You want to learn something through this data, and you practice using the data by giving the real, working on a real example. Then once you have real example, for example, you have CSV file, you can learn how to read this is a CSV file, for example, convert to data frame. Then after you convert it to a data frame, you realize you need to clean some data. Then you have to use drop NA. You also need to delete some rows, right? Then you do some data cleaning. And then as you want something meaningful from this data frame, you do some statistical analysis, like using describe. There are some other advanced features you can use. And when you describe it, you want to show to other people what you learned. You can visualize your data for scientific plotting. You may want, based on your needs, some people might look into specific rows, columns data, while others might think other data is more important. So they can slice in the columns or filtering rows. We also talk about group by function, give you a different bunch of options. You can also merge your data frame, especially if you have multiple CSV files. Then you can work on merging them and see, okay, now I have a bigger data frame. What can I do? Maybe you can have more meaningful insights by concatenating all different frames together. I mean, for this workshop, we just we'll give you overview of what's covered, what pandas can do. And then in your spare time, I think it's a good practice to just get some real data and work on analyzing, there are a bunch of advanced commands you can also learn, and it's all in the Pandas documentation. And after Pandas, we also want to talk about Matplotlib. As I talk about in Pandas, it can be used for visualization, but Matplotlib is, because Matplotlib specializes in visualization. So if you want to do specifically plotting, you might also switch to Matplotlib. But the good thing is that it all works with Python, so you can all import the stuff Matplotlib and then work on your data. Okay, there's some luck. For example, if you work with the Jupyter Notebook, my cursor's on the right, so you need to have this in place. It's called matplot inline. This is command specifically for using Jupyter Notebook. It kind of formats your picture better, works better for the Jupyter Notebook. If you're working on with a Python file, you don't need to include this. That's just something for you to know. Okay, Matplotlib, I mean, there are many different functions of Matplotlib, but today we'll focus on some basics. For example, 2D plotting. If I create a NumPy object, which is a line space from 0 to 2, I spread the points into 20 different intervals. And so it's evenly separated. For example, you'll create a NumPy array like this from 0 to 2 with the same distance in between. And then also import the Matplotlib package. Once we have the data, for example, we want to plot a figure, which is the x-axis is just x value. The y-axis is the square root of the x. So and then I want to use a red color and the circle. The O represents circle. So I want to plot a figure like this. So let's show something like this. And from 0 to 2, then we can plot the square root of x. If you want to change the color of your plotting, you can change this option. For example, you change the red color to blue, so you will just use a letter B. And you want to change the square, the circle stuff into the solid line, then just put a dash over here. And then you include the plot.show so that your plot can be shown on Jupyter Notebook. Then it will be something like this. Depending on preference, some people might like the one over the other. And you can also execute it over here. That's for Matplotlib. You can also generate multiple lines on the same figure, right? So right now I only have one single plot on the same figure. And what if I want to generate 3 different plots on the same figure? So I just put 3 lines of code. Each line is similar to what we talked about in the previous slide. For example, I want to plot a line which is use the x as x-axis. The y is just plotting the same value of x. I use a green color. I also want to give a label. Then it will just output a legend on the figure. Similarly, you can also have different other plots on the same figure and just change the colors and labels and show it. And then you can see after I execute this 4 lines of command, it'll give me 4 different lines of figure. Because I didn't put the legend option at the end, so the legend wouldn't show. But if you put the legend, then it will give you a legend over here. What if you want to have the multiple plots on the same figure? You can see instead of just giving different lines of command, I need to create a subplot function. So for example, plot.subplot function asks you how many rows of subplots you want. And this line, the second one asks you how many columns of subplots you want. The last one asks you to say, okay, which one do I want to activate? For this function, I have 1 rows of figure and 2 columns. So that means I want to create 2 subplots, but I want to execute the first one. And the first one is based on plotting the y equals x, and the color is green dashed. And then and afterwards I want to execute the second one, and it's based on the square root of x. And if I want to show it on the same plot, you can see, okay, it looks kind of nice. So I can compare why that value looks different. And it's line by line, so it's easier for readers to understand. Afterwards, most people, when they plot, after they plot something, they also want to save it, right? So that's kind of similar function as if you click on the save button. But Matplotlib, you need to execute a command. It's called plot.savefig, and you can give a name. Let's try it. I already have it here. Let me delete this one. For example, I right click on this. I think there's delete. Okay. Now it's gone, right? So let me execute this command. You see my figures here. If you double click on it, it will show up on your here. So it's the same stuff, but instead of on your notebook, then you can have a file save your home folder, which is kind of a nice feature. I think we pretty much cover almost all the stuff in the IPython notebook. So I gave you probably 5 minutes so you can practice a little bit about what we learned. So we have pandas, we have matplotlib on the same IPython notebook. So if you want to practice, you can just using this run button, run it by line and see, okay, give you a refresh of what we learned. So, okay, I'll give you 5 minutes so you can play around with Jupyter Notebook and see if you can change anything. For example, some people ask, I use index columns 0. What if I change it to 1? Or what if I just don't use this one? You can play around with it a little bit. And for example, if I want to change 9,900, what if I want to change this one to 0? You can try that. I will give you 5 minutes. Also, I'd like to mention that the Jupyter Notebook executes line by line. For example, if I execute this command, import pandas, import numpy, if I just want to jump, sometimes it wouldn't work as for example, this series objects is just based on the command execute this line 3. And if you don't execute this one, it will not work for this one. A lot of people, if they want to jump to a specific session, execute the command. Most often, what they left out is importing stuff. So you need to at least import some stuff over here. Also, sometimes your kernel might die, so you want to restart your kernel. So kind of like a restart your computer, so you wouldn't freeze again. And also you can change other function. For example, restart kernel, I run up to selected cell. So you wouldn't run all the cells. It will just run up to a specific cells. Also nice feature. You can also run all your cells using this command, restart kernel, I run all cells. Okay. I think that pretty much covers all the stuff about Pandas Matplotlib. And I just give you a summary of what we talk about today. So Pandas is mostly for data analysis visualization. You can use for importing different data structures. You can also transform your data different formats and can use for visualization. But talk about visualization, Matplotlib is specifically designed for visualization. So if you want to visualize your data, you can also choose to use Matplotlib, can be also a better choice. I think that's kind of something what we want to learn for today's workshop. I hope you can learn something from this tutorial. And some people mentioned they have problems with their on-demand. Probably we can talk about it here, see if we can try to address your issue. I think otherwise, I mean, this pretty much cover all the stuff. So you feel free to leave or feel free to stay if you have any questions. I'll stop sharing.
Hi.
Let me know if you have any questions about the workshop.
Hi.
Or if I miss any messages, you type in the chat, let me know, because I was focusing on the slides, might not see your messages.
Hi. Can you hear me?
Does anyone have questions? You have issues with using your VPN login? And I remember I got a message from someone. Is VPN